Hi, welcome to the International Space Station Flight Control Room. We are here where the Orbit 2 team now is monitoring the systems aboard the International Space Station and also the crew's activities. Here with me today, I have Tara Rutley. Tara, thank you for coming. Tara is the Associate Program Scientist for International Space Station. And so what she's going to do, we're going to have here today is a just a wrap up of it's this we're going to call this Science Friday. So what we're going to do today is have a wrap up of science that has been being worked on orbit all during this week, and then we have some other little things that we want to talk about that had gone up on the SpaceX Dragon spacecraft that is going to be leaving Sunday this weekend. So welcome, Tara. First of all, before we get into any of all this stuff, I just want you to explain to me a little about your roles and responsibilities here as the program scientist for International Space Station.
Sure. Let's see. Well, there are many. First and foremost, I'm involved in helping to coordinate the research plans that happen on Space Station and look across all investigations. And then, as the investigations are happening on orbit, I help identify impacts to science that may be important for pursuing or promoting the science that happens on station. So we help prioritize the science, make sure it gets implemented, we meet the needs of the investigators, and then after the experiments are done, our team works to get the results and turn them into something that's communicable to the public. So we try to communicate the value of what's happening on Space Station as well.
Okay, great. Okay, so we're gonna do a little recap of some of the science that's been taking place, and there's a lot of science, and I think that's going on. A lot of times we hear a lot about, oh, we had to fix this or we had to fix that, and while we got to understand that this is their home that is orbiting, so there is maintenance that is required, but meanwhile it is a laboratory, and we
Right.
don't want to forget that, and that science is taking place every day, 24/7, even when the crew is sleeping at times,
Right.
depending on what the experiment is or the study. So first, before we get into some of these experiments or investigations that are taking place this week, I want to go and talk about this education publication. There was a recent publication that was done and really kind of goes over some all the history of the space station science. You
Mm-hmm.
want to go ahead and talk about
Sure,
some of that?
yeah. Just this month, our office put out a new publication. It's called Inspiring the Next Generation, and it's basically a compilation of the results of the student participation in Space Station over the last 12 years. So just about every investigation that happens on orbit has some kind of educational component, whether it's true student design and competition, where it's actual student experiments on orbit, or it could be just all the way back to on orbit activities that can be pursued in the classroom in parallel, even crew call downs to students. All of these things are rolled into this publication in an effort to communicate the value of station in a way that promotes science, technology, engineering, and math. So the STEM is real critical, right, to space station value. And what we found is going through the publication as we were putting it together, looks like Space Station has reached students and teachers across 44 different countries
Wow.
in the last 12 years. And about 42 million students have been reached, and on some level involving space station activities, which is really mind blowing, and nearly 3 million teachers as well.
Yeah,
So
that's pretty
it was,
exciting.
yeah, it was pretty eye opening as we were going through. And now the publication also details how you as students and teachers can get on board and participate in competitions that are up and coming and that are always ongoing. So if you feel like this is something you want to look through, which I highly encourage, if you have ideas, if you're a student and you have some ideas, you're not sure where to go, this publication is really a great place for you to start because you can see what other students have done and some of the results and how you can participate. And to do that, you can. We have copies that are coming out in print this month, but in the meantime, it's online right now. If you go to www.nasa.gov/ISS-science, you can find there's a for teachers section and a for students section. And if you click on those links, there's lots of information there, and you can find the online version of in terms of PDF format for this publication.
Great. Thank you for
Yeah,
sharing
check
that.
it
That's
out.
really good good information there.
Hmm.
So let's go ahead and talk about a couple of the experiments that are taking place this week, and they're going to be ongoing. But one of the things I know is the Meteron, and this is something that Sunny was working with earlier this morning to deactivate and that sort of thing. Can you? I think we have a little picture here
Yeah,
of Meteron, and there
yeah.
he is.
This little guy is
Oh,
actually called Mock-Up, and he's part of the Meteron Project, which is an ESA, European Space Agency sponsored investigation that'll actually happen over a period of 2 to 3 years on station. And the goal of this Meteron project is to check out and just basically characterize and understand human robotic interaction from when you're on orbit and down to Earth. So it's a unique capability to be able to, what Sunny did this week, which was pretty cool, was she actually controlled this little creature called Mock-Up from ISS, and this Mock-Up is located at a ESA control facility in Germany. So she actually commanded it from space, and it was pretty exciting. The robot, from what I understand, is on in an area that's simulated with a simulated Mars environment. So what you're
mhm.
doing is simulating controlling a robot from far, far away in
Uh-huh.
space. And so I understand that the communication hesitation or delay was only 2 to 3 seconds from
Wow.
when Sunny sent the command to when the little robot did perform her command. So really what this is proving out is something called delay tolerance networking. And so a really critical component
Mhm.
of technology demonstration for use on space station is being able to use technology that is going to take us beyond low Earth orbit rate.
Mhm.
So delay tolerant networking is a series of network communications established for networks like space station that have loss of signal, and they're DTNs, delay tolerant networks on Earth as well.
Mhm.
So anytime that we lose signal on orbit, what happens is the little packets of information get stored and then can I guess you could think, projected forward once the communication is reestablished.
Mhm.
So this is a way for us to test out a very basic human-robot interaction along with the DTN network and think about how we would evolve these robotic features out past just this little mock-up robot. Now, mock-up's the first, but in the series over the next several years, ESA plans to progress and all the way up to exoskeleton type wearable components, human robotic interaction. So basically, you can don a big arm or a glove and control it that way versus just computer and joystick,
Wow.
which is up on station now.
Wow.
Yeah, so
Okay.
so Meteoron is a really good example, technology demonstration. It's very visible. It's really fun to watch, and we're looking forward to just more progression as this one
Yeah.
goes
So
on.
what she did actually with her commanding Meteoron or the mock-up from
Hmm.
the space station was almost a little reverse of what we see here, because here the ground teams will often be operating the robotics,
Exactly.
up on
Exactly.
station. So that's
That's
kind
right.
of interesting to see that.
Hmm.
Great. So another one we have here, I have a list. This one I like, just because I like fitness and this kind of
Me
thing. So I want
too.
to talk about VO2 Max, and I
Yeah.
understand it's not really that fun to do.
Right. It's pretty strenuous. Yeah.
So maybe Sunny enjoys it because she loves fitness so much, but I don't know. So talk to me a little about VO2 max. What exactly? I mean, it's your the measurement of your aerobic capacity, but tell me, why is this important?
Yeah, VO2 max. It's a measurement, like you said, of aerobic capacity. So how well the crew members can take up their oxygen as they're exercising, and it's done on Earth too, in athletes and anyone who's interested. And it's a reflection of your cardio fitness, your cardiovascular fitness, and your respiratory fitness, and that has huge impacts on your physical overall capabilities.
Mm-hmm.
And so, in terms of crew members, the reason why I want to check it out is because when the crew has to potentially maybe emergency egress. What kind of fitness are they in? What kind of cardio and respiratory shape are they in? Can they do it? Can they go on long, intense EVAs if we should go beyond low Earth orbit and arrive at a terrestrial location that they have to get out and start really manually laboring for a while? So the really cool thing about VO2 max is that it directly measures the crew as they're exercising. The crew breathes into a device and out of a device as they're really high intensity exercising. They got to go max. That's what the max stands for.
Sure.
So it's pretty intense. intense, and the device that they're breathing in measures the carbon dioxide to oxygen ratio that they are taking in and producing, and then their calculations back on how efficient their lungs and their cardiovascular system are. And with VO2 Max this week, there was the very last session that was performed ever. So they wrapped up a study that I think has been ongoing since 2009, and they needed 12 subjects to be successful. Human subjects. And human subjects is valuable and very sought after commodity on space station, but it's very critical to the human research program that we understand these things before we go beyond low Earth orbit. So it's really cool to get the last subject in. Now they needed 12, and they got additional 2 more for good measure. As a scientist, you want to make sure you cover all your bases and you have as much data as possible.
And so I understand, though, before they do this, they actually do their VO2 max, measure that before they leave, so they have a baseline for comparison, and then on orbit, and then
return again
on post-flight.
Yeah, pre-flight, in-flight, and on return to just measure across how much is lost, and then how much they actually will regain back once they land as well over time.
How they compare with some of the Olympics.
I don't know. Maybe Sunny will want to find that out.
Good high numbers. Okay, so the next one, this one's kind of a fun one too. And actually, we were talking about this earlier. Aki was actually just measuring the water volume of this particular habitat, and it's called the Aquatic Habitat. And this is kind of exciting because it's for fish.
It's fish.
Fish in space.
Yep.
So talk to me a little about this.
Yeah, this is fun stuff, right? So the Aquatic Habitat was actually itself, the hardware was launched this summer on an HTV vehicle. And in the meantime, the crew have been working on and off to set up the water, test the pH, get all the bubbles out. Surprisingly, bubbles are a bad thing to have in a fluid environment in space. Set up the filtration units and get ready for the fish that just arrived on 32S. And I heard as of this morning, the fish, Medaka fish, have been inserted into the aquarium. And so the purpose of these Medaka fish is to basically start an investigation that looks at the development of fish over time in microgravity. The longest time a particular fish has lived in microgravity has been about 16 days or so on space shuttle missions. And so now we're looking at a breeding tank that can hold fish over 3 different generations of breeding. And these fish breed pretty quickly, I think over 2 to 3 weeks. And so you can start to see different generations of development. And you can also look at them under a microscope. You can tag them with red and green colors that you see on the screen that drive certain cells to behave in a certain way. You can see what's happening with those certain cells. So if you tag bone cells red, you can see what's happening to the bone, the skeletal system in these fish as they evolve in a microgravity environment. Crew on orbit, the longer they stay, they face muscle and bone loss because of disuse. They're not using it as often as they are on Earth. And so we want to understand some of the issues associated with that, the processes that control that. And one way you can do it is through these fish, especially as you look at their development over time. So the first study will look at the bone development and then follow-on studies. I backed myself in a corner with that one. Follow-on studies will look at other different physiological processes of the fish. And really cool it would be to see just how they develop and what they end up acting like and looking like after generations in space.
Yeah.
So it's exciting.
So and you mentioned 32S, so that just arrived. So you're talking about the Soyuz with Kevin Ford and his 2 cosmonaut crewmates as well. So yeah, and they just arrived this week.
32 fish are now on station, and
very cool.
Most of them are inside the aquarium.
Very cool. Very cool. Okay, so last but not least, we have one other one, and Sunny was also working a little bit with it. I think just replacing it on station this morning. And this is called a Microsick.
Yes.
One thing about Microsick is it actually came up, and I want to talk about more other things. This is something that they're working on this week, but it is one that actually arrived at the International Space Station aboard the first resupply cargo craft, the commercial resupply cargo craft, the Dragon, which is actually set to depart from the station and splash down on Sunday. But so talk to me first. I want to talk about more science that was brought up on Dragon, but first talk to me a little about Microsick, since that's something that they have been working on during this week as well.
Absolutely. Microsick, it's what's called a sortie, and we haven't had sorties since retirement of shuttle. So a sortie is an investigation that you launch up on a vehicle, activate it, during the time that the vehicle's docked and then return it right away home. And since we haven't had return capabilities, we haven't had a sortie in a long time. So Microsix is one of two sorties that are on station right now, and it's coming home. Like you said, I saw the video of Sunny packing these what's called these gaps, these circular components inside of a return box that's coming home on SpaceX. And inside of these particular gaps, that's what the hardware is called, is a type of yeast called Candida albicans. And Candida albicans is a normal part of the microflora and flora that are located in your gut, and they're part of who we are. But sometimes, if your balance of these microbes inside your gut get off, these type of yeast can become more active and take over and cause issues such as yeast infections and thrust in the mouth. And so these infections can become an issue on Earth, but you can imagine they can also become an issue in space as well. So we're interested in them in terms of crew health. But what's really cool about the microgravity environment is that we found with the way bacteria behave and other microbes that sometimes certain ones become more aggressive in space, and so they'll upregulate their kind of nastiness. And so with that, we've been able to identify types of genes that are involved in driving that kind of aggressiveness. And if you can identify the types of genes that are involved in that behavior, you can potentially get to a cure or a vaccine or a treatment quicker. So that's what's being done with the Microsix investigation. The scientists who are sending this one up are going to get the samples home, and they're going to look at things like what genes were upregulated in these cells as they were incubated on space station in the microgravity environment.
Right.
And then they might think about what might cause their activation based on these genes that are activated. What's causing this? What about the microgravity environment that's doing it? They're also going to look at their physical structure, because sometimes when microbes become aggressive, part of that is that they create biofilms, and that's a good way for them to communicate and hang out with each other and become more aggressive. And then lastly, I understand that this investigation is also testing an antifungal treatment. So it'll be interesting to see the response in the cultures to this antifungal treatment as they were cultured in microgravity. So these guys are going to come home on SpaceX, and we're looking forward to those results. They're one of many that are going to come home. About 400 kilograms are coming home on SpaceX in support of countless investigations. My job right now is to untangle the countless number of investigations that are actually coming home.
Wow.
They range from cold stowage samples, which is a new capability for us as well. We haven't had that since shuttle's gone away. Being able to return samples that are frozen or cold, like the blood and the urine, the critical human samples, the critical plant tissue samples, things that have been up and in the freezers in space station for a while and need to come home before they expire, so to speak, and the cells start to break down. So the science return on these is critical, and that's a big return capability of SpaceX. And we also have some ambient samples coming home in terms of materials, even some ambient samples that don't require that are human-based, that don't require freezing as well. We also have physical sciences capabilities, some material samples that are being returned, and even videotapes of the data that was taken during investigations on orbit as well. So it's going to be fully loaded. We've maximized our capacity for return on SpaceX. About 200 kilograms went up on SpaceX to support about we have 165 investigations going on right now in this 6-month period. So it probably doesn't support every single one of them, but a good handful of those are being supported in the up mass of SpaceX, and the return is going to be really exciting.
It's going to be a big deal. Not just this, the splashdown and being able the scene of it all, but knowing that the stuff is home and it's returned safely, and we can collect and get some information out of there that could be useful to us, not only in space and our endeavor there, but also here on Earth, because some of these, a lot of these studies that we're doing, on the station also have application to us here on Earth. So I think it's very, very important. And as we know, we also the SpaceX Dragon is going to be splashing down on Sunday. It departs from the International Space Station Sunday morning. We'll have live coverage for you here on NASA television of the unberth and the release, and that will start at 6 a.m. Central Time Sunday. Again, watch that, and then we'll provide some video later that afternoon of the splashdown. And here are some of the time matches of everything that's going to be taking place. Again, the coverage will begin at 6 a.m. Central Time here on NASA television, with a release schedule for 8:26 a.m. and splashdown later at 2:20 p.m. that afternoon. Tara, thank you so much for coming here and
Thanks
giving
for
us this
having me.
Science Friday and giving us a wrap up again. Like I said, I think it's a very important element and something that we too often get caught up in the whole, we got to keep our home clean and maintained, but it is a laboratory.
That's right.
And so thank you very much. And we also have a website you can go to at www.nasa.gov /station/research, and you can find all the information you want.
Yep, that's it.
And then some.
Yeah.
And thank you again for coming out.
Thanks. It's always so fun to come talk it. So thanks for inviting me.
Great. Thank you.